All right, let's look until they call us outside. Let's look at problem number 11 and kind of start this one. All right, so on number 11, we need to find x and y. We cannot find x first. Why can't I find x first here? We don't have y. Why can't I find x first? I've got x here, here, and here. Special needs. All right, let's go outside. All right, so let's pick up where we left off. Why can I not solve for x first? What's the issue with solving for x first? Why can we not decide to do this one first? How many x's do we have? How many x's do we have? 3. On how many different sides? 3 different sides. Which sides would we set equal? Are any of them marked as congruent? Sides are never equal to 180. Angles are equal to 180. Don't set sides equal to 180. I will draw an unhappy smiley face on your page. The unhappy face, not smiley. All right, so the problem here is I don't know which things I can set equal to each other. So we're going to have to find y first. Y is right here. And I know 2 other angles. I know this angle, 54 degrees, which is also inside the triangle. And then I have this angle here that is not inside the triangle. What do we call angles that are not inside the triangle? We call them exterior. This is an exterior angle. And Yasmin, you were onto something, though. These other 2 angles that are inside the triangle would be what? Remote. These are my remote interior angles. And we learned at the very beginning of this module the exterior angle theorem. The exterior angle theorem says that my exterior angle is equal to the sum of the remote interior angles. So how big is my exterior angle again? (108 degrees). And that is equal to the sum of the 2 remote interior angles. How big are the 2 remote interior angles? 54 and y. So 54 plus y equals 108. So now to find y, I just need to subtract 54 from both sides. What is 108 minus 54? It is 108 minus 54. (54). So y is 54. Well, if y is 54 degrees, and this other angle that they gave us is also 54 degrees, I have 2 congruent angles inside this triangle. So what kind of triangle is this? This has to be an isosceles triangle. 2 congruent angles means it is an isosceles triangle. And isosceles triangles have how many congruent sides? 2 congruent sides. How do we find which sides are congruent? Because that's the key to finding x. How do we figure out which sides are the congruent sides? How do we find which sides are the congruent sides? It's not all three of them. There's only two sides that are congruent, and I have to figure out which two it is, because if I don't set the right two equal, I'm not going to get the right answer for x. I know which angles are congruent. That's this angle up here and this angle down here. How do we find the two sides that are congruent? The two sides that are congruent are the ones that are opposite the two angles that are congruent. So this is one of my congruent angles. This is the side that is opposite that angle. So that's one of my two congruent sides right there. What would the other congruent side be? Yep, 7x minus 14, opposite that top angle, this guy down here. So now I know that I can take 2x plus 16 and set it equal to 7x minus 14. 2x plus 16 equals 7x minus 14. To solve this for x, I need my x's on the same side, so I'm going to subtract 2x from both sides. What is 7x minus 2x? Close. 7 minus 2 would just give me 5. 16 equals 5x minus 14. Then we add 14 to both sides to make it cancel out on the right. What is 16 plus 14? 30. So I have 30 equals 5x. And so x equals 6. We divide both sides by 5, and x is 6. Nicely done. All right. After number 11, the next one that was requested was number 9. So let's hop back a couple problems and look at problem number 9. Number 9 is a proof. My first statement is going to be my given information. And because of how much space I've got, I'm going to put it on two separate lines. So I'm going to put this as my first statement, and I'm going to put this as my second statement. A lot of times I'll put that on just one line. If I end up needing an extra box at the bottom, I'll draw an extra box in, but I can't squeeze all of this into just one of those two tiny boxes. Guys, phones need to be put away. D is the midpoint of segment BC, and AB is congruent to CA. We can make both of those statements because it is given. All right, so now let's go mark up our triangle. AB, that's this right here, is congruent to CA, that's this right here. And we were also told that D is a midpoint here for segment BC. Well, if D is a midpoint, then what else would have to be true? D is in the middle. I don't know anything about A. D is the midpoint. What does that mean about this? Yep. BD and DC would have to be congruent. Why are we allowed to say that? What was it that tipped us off that those two segments were congruent? We were told about a midpoint, right? So why can I say this? Midpoint theorem, yes. Is there anything that I am allowed to mark as being congruent on the triangle even though it wasn't part of the given information? Shared side. We have AD is congruent to AD. Why am I allowed to make that kind of a statement? Reflexive property. That's what you were trying to talk about before? Yes, and that is true. It doesn't come from the midpoint part, which is what I was asking about at the time. But you're right, AD is congruent to AD. And we could have written that down right here if we'd wanted to. It doesn't have to be step 4. It could have been step 3. Let's look at everything that we've got marked up. I have 2 triangles that are marked up identically. Do I have enough to say that these 2 triangles are congruent to each other? Yeah. Yes, using what? Using what? I've got 5 different ways I can show 2 triangles congruent. Using side, side, side. We have all 3 pairs of sides marked as congruent. We can use side, angle, side, hypotenuse, leg, angle, side, angle, 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 side, or side, side, side to show 2 triangles congruent. What'd you say? Hypotenuse leg, HL. It's when the hypotenuse, so what it would look like is we would have to know that we have a right angle. If you don't know you have a right angle, then you cannot use hypotenuse leg. We would have to have congruence marks on the side that is opposite that right angle. And we would need one other side with a congruence mark on it, either this one or this one. That would be our leg. All right, let's finish writing our triangle congruence statement. Triangle, let's call the first one BAD. Triangle bad is congruent to angle B up here corresponds to what on the other triangle? C. So C A D. CAD. What are we trying to prove in the end? Yep. We want to show that angle ABD is congruent to angle ACD. That is CPCTC. Those are corresponding parts of congruent triangles, and so they are congruent. We just showed that the triangles were congruent right here. CPCT, thank you, C at the end. Sorry. CPCTC. Thank you for catching that. All right, so we did number 11, we did number 9. Number 4 was the next one that was requested. Let's go look at number 4. Using the picture, find the angles. BDC. Angle BDC. B down to D over to C. Is that angle inside or outside my triangle? Outside. So what do we call it? This is an exterior angle. If that's an exterior angle, what do we call these two? Remote interior, yes, because they don't touch our exterior angle. These are remote interior angles. And my exterior angle theorem says that the exterior angle is equal to the sum of the two remote interior angles. So that exterior angle is angle BDC. So the measurement of angle BDC is equal to, sum means to add. What two things are we adding? 42 and 37. 42 degrees plus 37 degrees would add together to give me what? 79 degrees. So angle BDC is 79 degrees. I'm going to add that to my picture. 79 degrees. And what do we know about these two angles? They're a linear pair. So the measurement of angle BDC plus the measurement of angle BDA has to add up to what? Has to add to 180, and so it would be 101. Yes, because we'd have 79 degrees here plus the measurement of angle BDA is equal to 180, and then we subtract 79 from both sides. Yep, angle BDA is 101. So one thing I want to say before we move away from this problem, and we did another one that had that remote interior angles and exterior angles. Last year on this test, that was the most missed problem, was ones where you had to use the remote interior angles set equal to the exterior angle. It was also the most missed question on our first skills check in this module. So the remote interior angles, you add the two interior angles together and it equals the exterior angle that they do not touch. All right, so that's number 4. Number 12 was next on the list. Let's go over and look at number 12. In the diagram below, find the measure of angle B and the value of x. So what we know in this problem is that we have a 60-degree angle down here at C, and I have these congruence markings here on AC and BC, which means this is what type of triangle? Isosceles triangle. Isosceles triangle has two congruent angles and two congruent sides. Which angles would be the congruent angles here? We just did this a moment ago, but in the other direction. How do I find the two congruent angles? B and A, opposite my sides. So opposite this side would be this angle right here at A. Opposite this side right here is this angle at B. So those are my two congruent angles. I don't know how big they are, but I can use the same variable for both of them. I can't use x though. Why can't I use x? We already have x's there. So I have to pick something different, a variable that's not being used. This expression and this expression have x in it, and it's not the same as the angles. So I could use y. So this would be y degrees. This would be y degrees. Yep. Measure of angle A plus the measure of angle B plus the measure of angle C. Those three angles will add up to how much? The three angles in a triangle add to 180. Angles inside a triangle add to 180. So A, we called Y. B, we also called Y. And C, we were told in the picture, was 60 degrees. So Y plus 60 equals 180. I'm going to put the Y's together. So that gives me 2Y plus 60 equals 180. Yep, 2Y equals 120 when we subtract 60 from both sides. And if 2Y equals 120, how big is Y? 60. So this angle over here is 60 degrees. And this angle down here is also 60 degrees. It is an equilateral triangle. You're absolutely correct. We said it was isosceles, which is true, but all three angles are congruent. We had one like this on the skills check. Because it's an equilateral triangle, because all three angles are 60 degrees, what does that mean about the sides? They're all equal. So this side here, BC, is the same size as AC, but it's also the same size as AB. So segment AB is congruent. Thank you. She's actually the nurse. Sorry. You're welcome. Is congruent to BC. So the length of AB is equal to the length of BC. We were told that AB is 2x minus 1. That's on the picture. And BC is 3x minus 7. We get our x's to the same side by subtracting 2x from both sides. I get negative 1 equals x minus 7. Then we add 7 to both sides. And that means x is what? X is 6. Nicely done. All right, there's still quite a few problems on the list. We have 10 minutes left. I will get through as many as I can in our last 10 minutes. Number 1 was the next one that was requested. So it tells me in my given information right here that angle ABC, this angle right here, is congruent to angle ABD, this angle right here. Those two angles are congruent. And then it also says that angle CAB, so this one up at the tippy top, right here, is congruent to angle DAB, the other side of that tippy top angle. What other piece of information do you know from the picture? What are we allowed to mark even without being told? There's two things that we're allowed to mark in pictures without being told. What are those two things? Shared sides and vertical angles. Do we have a shared side or vertical angles here? We have a shared side right here. So we can say that AB is congruent to AB. Write a congruence statement for the two triangles. Let's call the first one CAB. What corresponds to C on the other triangle? D. So I would have to start this triangle congruent statement with D. Yep, DAB. Remember, we have to match up the corresponding congruent pieces, and A on the left triangle is congruent to A on the right triangle. Name the postulate or theorem that's being used. So look at just one of the triangles. What do we have marked up? Angle, side, angle, yes. If we wanted to use angle, angle, side, we would need an additional part marked congruent. So there's a couple different things that we could do here if I wanted to use angle, angle, side. If I know that angle C is congruent to angle D, if I had that, then I would have angle, angle, side. Or if I knew that CB and BD were congruent, then I could do angle, angle, side. So CB and BD. Or we could even go as far as saying, if I knew that AC and AD were congruent, then I could do angle, angle, side, like that. So AC and AD. All right. I have 5 minutes left, and I think that's just enough time to get through number 20, the very back problem. So go from the front of the packet to the very back of the packet. We're going to take our given information and put it in these top two boxes. I want the second piece of information in the second box because there's nothing more that I can do with IM congruent to KN. No more useful information will come from that. Let's mark them as congruent on the picture. But from IM parallel to KN, I can get some more information. What shape do we draw when we see parallel? Draw a Z. When I come in and I draw my Z, I have to go over the parallel lines and I have to connect them with the transversal. So this is one possible Z that I could draw here. And then orange to orange, orange to orange. So angle MIL is congruent to angle KNL. Because those angles are what type of angles? Alternate interior. So by the alternate interior angles theorem, we can say that these two angles are congruent. That is not the only Z that I could have drawn. I could have gone the other direction like this. And if that's the case, which I can do because it's connecting my two parallel lines with a transversal, then I have this angle down by M and this angle up by K. So angle IML is congruent to angle NKL. For the same reason that my orange angles were congruent. It's still parallel lines. I still drew a Z to find it. So this would be the alternate interior angles theorem. Look at just one of these two triangles. Let's look at this one. How do we have it marked up? What's marked on the picture? Angle, side, angle. The side is in between my two marked angles. The side touches both of those angles. That's how I know it's angle, side, angle. And I could say that triangle LMI is congruent to triangle LKN. But what we wanted to say at the end was that segment IL and segment LN were congruent. IL is congruent to LN. Those are parts of two separate triangles. Why could I say that those parts of two separate triangles are congruent to each other? CPCTC, corresponding parts of congruent triangles are congruent. And we just showed those triangles were congruent right up here. All right. Unfortunately, that is all I have time for. The other questions that you guys had about 16, 19, and 14, I was able to go over those questions in first and second period. So you'll probably want to check out the videos for first and second period as soon as those are posted. On our Canvas page, you want to go to today's Canvas page, Wednesday, 11/13, review for Module 5 test day 2. Right here, in about 2 hours or so, I will fill in those videos so you can check them out for first and second period. You might also want to check out 7th period. Down at the very bottom, we have the answer key for the test review with all of my work on it. So you can see everything there.